right? This is another kind of common problem that they give us, right? And that is, it's example 10. I think there's a homework problem just like this. So when you get to the one that's talking about airplanes and winds and things like that, go to this example. Don't tell me, I had no idea what I was supposed to do. You should be able to follow the example. It's almost like interchangeable, right? It's the way that it's worded, everything. Here's the picture. An airplane is traveling at a fixed altitude with negligible wind velocity. The airplane is headed north 30 degrees west. What does that sound like? It's a bearing, right? It's the reason why we did bearing when we did. So if it's going north 30 degrees west, then the direction angle is, with the positive x-axis, 120, right? It's 90 to here. It's 30 degrees past 90. Okay, it's flying at 500 miles per hour. So that tells us that the magnitude of that vector is 500. Okay. As the plane reaches a certain point, it encounters a wind with a velocity of 70 miles an hour in the direction of north 45 degrees east. Okay. So north 45 degrees east would be something like this, right? There's 45 degrees. Come on, pen. But what does that make the direction angle? The angle with the x-axis. 45, right? Because they got to add up to 90 degrees. Well, this V2 right there, that's the 70. That's 70 miles per hour. So that's 70. This one was the 500. So this one's 500. Okay, they're asking us for what are the resultant speed and direction of the plane. Again, what does resultant mean? The sum of the two, right? So if you take this vector and then you tack on the end of it this vector, then you get the resultant, which would be this vector. And we want to know what is the speed and direction.